Good day everyone, I'm Carl Jason L. Corporal and this is my video documentation for my project for the course Digital Communication Laboratory, and this is a PMW circuit. Now, my PMW circuit consists of two parts, the oscillator part and the remaining PMW parts. Now, this leftmost part is the oscillator part, and this rightmost part is the remaining PMW components. Now, let's first talk about the oscillator part. Now, this oscillator is a twin T oscillator. It is composed of a comparator, series of voltage sources, series of resistors, series of capacitors, and ground. Now, our professor tasked us to give an output frequency of a frequency range between 100 Hz to 1 kilohertz. Now, to achieve that, we need to manipulate R1, R2, and R3 in a way that we will compute it. We will do some calculations to achieve uh, the desired frequency range. So that I use 20 kilohertz, and 10 kilohertz to achieve somehow 600 to 700 hertz of output frequency. Now, R1 and R2 must be the same because, again, this is a twin T oscillator, and it is a characteristic of that. And for our comparator has the positive port and the negative port. We attached um, positive voltage and negative voltage to achieve somehow an AC or an alternating voltage source. So now for the positive port, we attached positive 9 volts, and for the negative port, we attached negative 9 volts. Now, our professor tasked us that we need uh, to get a sampling rate of at least 3000 hertz. Now, to achieve that, we need to compute the time. So we know that frequency is equals to 1 over t, so that time is equals to 1 over f. Now, if our f is 3000 hertz, so 1 over 3000 is 3.3333 times 10 raised to negative 4. So we put we placed our maximum time step here as 3.3333 e raised to negative 4, so that we achieve that sampling rate of 3000 hertz. Now let's talk about the Vout1. Vout1 is actually the output of the oscillator, in which it is represented as a sine wave. So if we simulate the circuit and we look into the output of the waveform of the Vout1, there we actually see a sine wave. So this is the output of our oscillator. Now to check the frequency, we just place the cursor in one of the waveforms. There you go. So there you go. The frequency here is shown. It is 546.9697 hertz, in which it is allowable because our desired frequency range is between 100 hertz to 1 kilohertz. Now that we are finished with our oscillator, we then go to the remaining components of our PMW circuit. Now, the remaining components is another comparator, in which, by the way, I use the same op-amp, the LTC6244, in which has a characteristic of 50 millihertz, low noise, rail-to-rail CMOS op-amp. This is used for the oscillator and the PMW part. And we used a series of voltages and NPN and resistor and the output of voltage output. Now I will talk about the input of the voltage input of the second comparator will be the output voltage of the oscillator. So the output voltage of the oscillator will be the input voltage of the remaining PMW parts. And then we placed positive 9 and negative 9 volts again in the positive port and the negative port to again achieve alternating voltage source. And we attached 5 volts voltage source here, in which we can change this into voltage range of 1 volt to 8 volts, because we need to, this voltage must be lesser than this voltage so that the output voltage of the U2 is smooth. So the next is we're gonna talk about is this NPN junction. So this is the collector, base, and the emitter. So for the collector, we attach a VCC of 12 volts, voltage source of 12 volts. I chose 12 volts because it is a standard voltage. And for the output of the comparator, it will go to the base, and the emitter of the NPN will be the output, voltage output. Now I attach here an R6 for safety, so that the voltage output is smooth and just not going through the ground. Now, the voltage output 2 is actually represented as a square wave or digital binary form. Now, if we simulate it and we look into the V out 2, there you go. It is a square wave in which we have a frequency of, output frequency of, let's check. Oops. Let's try that again. Technical difficulties. There you go. It is 856.66667 Hertz, in which it is still allowable because, again, our range is 100 Hertz to 1 kilohertz. And that is it. That is my PMW circuit, and I showed you the simulations and I've explained the parts.